Hi, in this video I'm going to do the cyclic voltammetry of ferricyanide upon a screen printed carbon electrode. Now we do appreciate that one of the sort of best value, I think, in terms of cost and quality ratio is actually a hyper value carbon electrode. Now I've got one in front of me here and I will be testing upon it. But we've also got these electrodes in this kind of cartridge format as well. Now the cartridge format, why do we have this? Well, it's really because at ZP, we really, even though if we're doing education and research support, we really always got an eye on actual commercialization. So just simply asking a real person to handle something like this, you know, it may be acceptable for an R&D format or a teaching format, but in the, let's say it's quite awkward actually, in the real world, you really want to give somebody a user experience that's so much easier. You know, I can grip this without touching the electrode. It's wider, you know, so there's a reason why we have the cartridge format. But that said, in a kind of educational context, you basically need the sort of lower cost, I would say. So in that case, this is when the hypervalue carbon electrodes make sense because we do them in kind of sheet format. And therefore you can get kind of 300 in a sheet. It's a perforated sheet, by the way, so that means you can easily remove the electrodes from the sheet, but that then really helps in that kind of teaching format because they're basically less than 90 cents each. So, you know, less than $1 each, less than €1 each. Let me go forward now and just do a quick demonstration. So what I want to show you is that I've got the sensor or potentiostat here, and what I've done is I've put one of these into it. So you don't necessarily. Now, we've designed the sensor or potentiostat to really take this kind of format, but in fact it will still accept this format. So in fact I'll put them next to each other. So it's almost like a Premiere and a sort of same quality but a lower cost and not so handleable. So what I'm going to be testing today is this version as opposed to this version. You would almost do your R&D on this because then one day you can give a proper user experience if you use this to actually go to market with this. And I've got the cyclic voltammetry set up. It's in Bluetooth communication. I will put 50 microliters of ferricyanide onto the electrode. That's not showing too well. But this is a part number from Zimmer and Peacock. It's a ferricyanide solution. Anyway, 5 millimolar, by the way. All right, I'll put the solution on, which I am doing. And then I will actually give this a name so I can find it later on. I will call it 5 millimolar hypervalue because that's the kind of, it's the name we gave it when we first hypervalue carbon. Right, so this means now I can run this and I can find my data later on. I'll go continue. So I'm going to start at minus 600 millivolts. I'll go to 600 millivolts, scan rate 110 millivolts per second, repeat of 1, current range 100, and I'll start the measurement. And then it goes, and I can see the first peak appearing for the oxidation of. Because I started it at a negative potential, basically the ferricyanide became ferrocyanide, then we reoxidize it. Now it's kind of turning that, change the potential. It's done the experiment. I did it deliberately fast, you know, at kind of 110 millivolts per second, just to not spend an awful lot of time talking about it. And then what it does is it gives you the signal in real time, and then it actually uploads it to a cloud system called Julie. So I'll just share my screen with you now. I put it in a cluster called demo. So let's go to demo, and there it is. That's the instrument I'm using, or the sensor or potentiostat that I'm using. There's that 5 milli hypervalue carbon electrode, so it's gone up to there, and I can see my data. Yeah, it's a really nice voltammogram for 5 millimolar ferricyanide. Something that's available from ZP on a hypervalue carbon electrode, but not the hypervalue electrode in the nice cartridge. The cartridge is great for convenience, but it's actually a hypervalue electrode in a kind of, I took it from one of these sheets, and these sheets are perforated, so it's easier to sort of take the electrodes out and use them then sort of in teaching or in research and development. If you have any questions regarding this, don't hesitate to reach out to us. Okay, thanks very much.